Everyone, my name is Noah. This is Omar, Isaiah, and Christian, and today we're going to be talking about web performance and optimization. So what to expect from today? First, we'll be talking about why performance matters, analyzing speed with some dev tools that you should know, tree shaking with Christian. I'll be talking about network optimizations across the full stack, and finally, Omar will talk about caching and API optimizations. So what exactly is web performance? Web performance is ensuring content is quick to load and responsive to user interaction. We found this one from the internet, so it must be true. What we hope you get out of today, we hope you understand that on the web, when you're doing web development, every millisecond matters. So every little performance gain that you can get really matters for your end users. So I'll hand it off to Isaiah to talk about why web performance matters. Isaiah?
Okay, so why should you care about web performance? You made your website, it works. Well, first, you should care about search engines. Search engines care how fast your speed is. And that's pretty important because a lot of web traffic comes from search engines. So say your competitor has a slightly faster website than yours, and they rank just above yours. I don't know about you guys, but I definitely clicked the first link on Google. And so now you just lost a user, and that's going to be very disappointing. You may have just lost money if you were e-commerce or something. Okay? So let's say someone found your link on Twitter. Well, they're on your website now, but you want to keep them. You want to retain them. And you also want them to take whatever action your website was meant to do, whatever that be, read a blog post or make a purchase. That's often called conversion. So the better performing your website is, the more conversions you will get. For instance, when Pinterest reduced their perceived load time by 40%, they increased their search engine traffic and their signups by 15%. Now, 40%, that's a pretty big number. That probably took a lot of work for them to do. But like we said, every millisecond counts. In another instance, Cook, a website that sells frozen meals, found that just by decreasing their average page load time by 850 milliseconds, they increased conversions by 7%. Now, on the flip side, what happens if you don't optimize? Well, we live in a pretty fast-paced world. We want things to happen instantly. If a website takes too long for me, I usually go to somewhere else, go to Twitter, go to Instagram. If that's not working, go to Reddit. So Google found that 53% of mobile site visits were abandoned after 3 seconds. That's all you have. You have 3 seconds to get your user's attention, and that's it. In another study, the BBC found that they lost an additional 10% of users for every additional second that their website took to load. Now, there's also been rapid gains in emerging markets somewhere else. Like, the whole world is getting connected, basically. But if a website works on your super nice, newly built computer with your broadband internet or your flagship phone on 5G connection, that doesn't mean it's going to work everywhere. You're going to be losing on a lot of potential users if you just optimize for that. Some people still have 2G internet, and some people are using lower power devices that might be able to handle all your JavaScript. And that's potential lost users. So why should you care about web performance? Because it's a foundational aspect of good user experience. So next, I'm going to show you how to analyze a speed of a website using dev tools in Chrome, and also a tool called Lighthouse. And excuse me, I am always awful at using a Mac, so this might take me a minute. I don't understand how the mouse works at all. Or really how this works. Hey, Noah. Noah.
Isaiah, it's intuitive. Come on.
I don't know. Oh, God, he's using a touch bar.
There you go. So this could be awkward.
It could be awkward.
All the way up here.
Oh, cool. All right, so this is going to take me a while. Oh, and I cannot see how to get the... Where is the...
Do you want the dev tools?
I do want the dev tools.
Okay.
Okay, we're going to dev tools. I wanted to show you how to get to it in the menu, but...
Okay, sorry.
Oh, no, this is going to be awful. Okay, I will try to do it from here. So first thing I'm going to show you is audits in Chrome. So I opened up the dev tools in Chrome, and I pulled up the IEEE website. And this is the easiest way to figure out how well your website performs. So I click on audits here, and this is Lighthouse. This is how you can use Lighthouse in Chrome. You can use Lighthouse separately too, but this is the easiest way to run it. So I'm going to choose, let's use a desktop device, and I'm going to uncheck all these so it's faster and just focus on performance. So you can also see that when it runs these tests, it's going to simulate a slow 4G connection. So that's taking into account different connection speed. It's also going to simulate a 4 times CPU slowdown for a lower performing device. So when you run an audit, it refreshes the page, it does a lot of things. It might take a couple minutes, it's warming up. Not a couple minutes, it's gotta be done pretty fast. It gives you nice little facts about why increasing performance is good. And then we get that. We get a final number. It's all right, it's 21. It's out of 100, but the important thing is, so I'm gonna click here because that tells you what all of these words mean. What does first paint mean? Speed index, time to interactive. Time to interactive is probably the most important number you see here. That's the amount of time it takes until the user is able to do something on your website. And then when you scroll down, it doesn't just give you this number. It also gives you very helpful advice. So down here, it shows you the screenshots as it was loading. So you can see there's a lot of white screens here. That's when your user is going to leave. When they see just white in 3 seconds, they leave. So then it gives you a bunch of helpful suggestions on here. It gives you opportunities, so like enable text compression, reduce server response times, remove unused CSS. And what's also nice is, okay, see, this is me not knowing how to use the mouse. Why does it pull up the dictionary all the time? I'm using 1, maybe 2. So it's even smart enough, it knows that they're using WordPress, so it suggests using certain plugins for WordPress that would take care of these things for them. The next thing I want to show you is probably my favorite part of Chrome DevTools is the networking tab. This shows everything that goes from your website to your computer and to your computer from the website, all the assets, images, pages. So the important things if you're wanting to know the performance of your website is down here shows how much data was transmitted. You want to keep that pretty low. And then this waterfall over here shows you when things started loading and why it took long, it was stalled, or it was waiting for a server. And you can see the bigger this is, the longer it took to download something. And then you can also sort by size here, and you get, so here you can actually see that a lot of this was served from the cache. So that's something useful to know, to make sure to know that your caching headers are working. Yeah, and then I'm going to show you this performance tab. It is super complicated. I'm just learning how to use it. But it does, when you do it, you can do it anytime. I press a button to make it reload and then run this tool. You can do it at any time. Say there's a part of your website that you find slower. You can press that record button and then take that action, and it'll create this for you, which is everything that's basically going on your website at that time. It takes screenshots. It shows you the JavaScript heap. It shows you how much memory is used if you select that. And then you can even like drill down to certain things, so you can get down. It's hard to see, but this is a call stack, so you can see how long a function took and try to reduce that. Yeah. Final thing I'd like to show you in Chrome DevTools, this is something I just found out recently, is that you can go to the console here, and if you, this verbose isn't always selected. If you select this, and then just leave it open, I always have all of the levels selected. It shows you if any load event or any event handlers took too long to load, or if any of your JavaScript caused reflow or changed the style, which can affect performance dramatically as well. Cool. So now we have a question. Yeah. Okay. I have a question. Yes.
Okay, so let's go back into here. And, oh yeah, got it. I don't actually use this very often. Okay, so next we're going to talk about tree shaking. So let's go shake some trees. Tree shaking is not actually shaking trees. The idea behind tree shaking is to eliminate dead code in your JavaScript. So what that means is a lot of the time when you deploy code to your users, there's a lot of it that never actually gets run and literally could never get run. It's not possible. So the idea there is to eliminate that, which will reduce your bundle size. The reason for that is that JavaScript is more expensive byte for byte than pretty much any other data that you send to your user, because you have to unzip it, You have to parse it. You have to make sure it's valid. You then have to run it. So byte for byte, it's the most expensive thing you can serve to your users. And so you want to minimize it as much as possible. But before we talk about tree shaking, we have to talk about bundling. Bundling's current leader is Webpack, but it was invented by an older framework called Rollup. What bundling does is it takes the data that you have in many different files across your repository, typically just JavaScript, but you can also do things like bundle your CSS, bundle your images, things like that, and it puts them all together into a single file. So instead of serving 8 JavaScript files, you serve 1 JavaScript file. It's especially useful if you're going to send it to users with older machines that might not be able to run more than 1 file of JavaScript at a time, which is a thing. But today we're going to talk about why bundling makes tree shaking possible. So this is really what actually makes tree shaking possible in the first place. This is the import syntax for JavaScript. This was introduced in 2015 with ECMAScript 2015, ECMAScript being what JavaScript's spec is essentially. And it replaced CommonJS's require syntax. What this means is that you can import things from other files. People who haven't been writing JavaScript for more than a couple of years might not realize that this actually didn't exist. It's very nice. So let's go into an example of what a typical project might look like. This is just a couple of example files. They don't actually mean anything. We've got an app at the bottom, and then that's going to import stuff from stuff, utils, API, stuff and API imports from the nav, and we're going to import from something called Lodash in the node modules. So there's a bunch of imports here. And the important thing to understand here is that ECMAScript 2015's import syntax is different from the older syntax by CommonJS in one very important way. This can be evaluated statically. What this means is that before you run any of the code, you can parse the syntax tree and determine statically what code can be run. This is not possible with a lot of other import functionality, but it is possible with this, and that's huge because it means that you can essentially traverse the tree of the code and determine what part of any given file is going to be run. That's what allows us to get rid of all the dead code. And an example of this is maybe we're using all of the stuff in most of the files. So the blue boxes here are what's actually going to be imported. So our nav and our stuff file, it's got most of it, API, some of it. Lodash, we're using one little function. So notice that almost none of that is actually useful to us, and yet we're going to go send that to the user and say, nah, you're going to take all of it, you're going to run all of it and use none of it, which isn't very helpful if, for example, they're on a slow connection and you've just doubled their bundle size with your libraries, which is common because a lot of these JavaScript libraries are very large. So how do we only import what we're actually using? How do we actually do tree shaking? It's relatively simple. You change your import syntax from importing a module to importing things from a module. So instead of importing the actual name, you put it in brackets and you import individual things. These can be functions, these can be objects, arrays, literally anything that a JavaScript file can export. So an example, let's say we've got a 1 megabyte module and we really only need 2 things that are 100 kilobytes. We'll only import those and we get a 900 kilobyte savings when we bundle it all together. That's huge. 900 kilobytes may not seem like a lot, but in a world where the average website size is rapidly progressing above 5 megabytes, 900 kilobytes doesn't help, and especially when you consider the fact that this is about 3 times as expensive to parse as an image. So we've got this. This is one part. This is the part you do in your code. How do you get Webpack to say, I support this? That's relatively simple. You go into your Webpack config and you just turn on one thing. You go to optimization and turn on used exports true. That will tell Webpack only look for code that can actually be run, because that's what tree shaking is actually doing. It's not shaking off all the dead code. It's really going in and picking the stuff that you're actually going to use. And this is a little simplified. This is the actual syntax, but it's relatively simplified in that there are a couple of gotchas with specific modules, things of that nature that aren't always very clear and can trip you up. If you're using something like Babel, which is a JavaScript transpiler that compiles your JavaScript to a lower level or multiple levels for your users, that usually gets in the way of this. Various other things can also cause problems. If you're in a new project that's only using new JavaScript, you're probably good. Otherwise, you may need a little bit of help. And a great resource for that is this, which is a post by Google. You can just literally Google Google developers tree shaking. This comes up. This has a lot of the very quick ways to solve those problems, essentially. But now we can see the results of what we've done. So instead of a couple of massive files, we've significantly reduced the size of any given file that we're importing. Other than the stuff where we're actually using all of it, like Lodash in the top right there is now teeny tiny, when it was absolutely massive and causing us issues and load times and tons of problems. So use tree shaking. It allows you to use all these really nice NPM libraries without having to deal with how massive they are.
We are going to be talking about network optimizations across the stack. And what if I told you that ugly code is good? What would you say?
It has a good personality.
This is probably the only time that you'll actually hear this, ugly code is good. But yes, in the web world, code that is minified, ugly, and concatenated is far superior to very pretty code. But note, this is only for production. Generally, when doing web development, it's best to have clean and pretty code when you're developing, and then use a tool such as Webpack, Uglify.js to minify and concat your CSS, JavaScript, and HTML. Note, by default, Webpack will actually do this for you on your behalf, so that's pretty cool. So let's talk about minimization and concatenation. These are two key concepts. So to illustrate the importance, here's on the left example of code that has not been minified or concatenated, and on the right is code that has been minified and concatenated. We reduced the number of requests from 12 to 8 after doing this process, and reduced the amount of data by 84 kilobytes. That's 33% savings. That's pretty awesome. So with minimization and concatenation, we take a bunch of JavaScript files in this example, minify them, so we're just taking out all the white space, reducing the variable names, doing whatever we can to reduce the file size, and then concatenating all those files together. So pushing all the files together into one big file. So that's how we got down from 12 files to 8 files for this website. So that means fewer network requests and more lightweight network requests. So that's 33% savings for this, so I'd say that's a pretty cool optimization. Next up is DNS prefetching. So what in the world is this? DNS, like most things, is a complicated subject. Let's talk about it. When an HTTP request is made, and it's cross-origin, that's to a domain that is not yours, a DNS lookup is made on the browser's behalf, right? If the browser hasn't already seen that domain. A DNS lookup is a time-consuming process, potentially up to a few milliseconds, hundreds of milliseconds, who knows? This is very undesirable. We want to be getting the content to our users, not looking up where a domain name is. That's undesirable. So DNS prefetching is this really cool feature where you can pop in this one line of code, link relative DNS-prefetch, and throw in a domain here. This will, on load, tell your web browser to go ahead, and if the web browser hasn't already looked up the DNS for this domain, go ahead and do it now, because later, sometime else when a resource is loaded, such as this font, we want to reduce the time that it takes to make that request because the DNS prefetch has already been done, so we can get straight to the content. Note that here in this case, I have https://, but that doesn't really matter. It could be HTTP, there could be nothing there because this is not an HTTP request. We're just looking up a domain name, so it doesn't really matter. So this is also a really cool optimization that you can use. Next up, let's talk about images. Images are pretty important on the web, and images can weigh a lot. We're going to talk about WebP, responsive images, and source set. WebP is an alternative image format that has lossy and lossless compression. Okay, but what does that actually mean? It just means that WebP is really lightweight and fast. It's an alternative image format that was developed by Google specifically for the web. To illustrate how good it is, here's an image on the left and an image on the right. These are the same images. The images on the left weighs in about 250 KB, and on the right, 172 KB. That's a savings of 78 kilobytes, and these images are indistinguishable. That's 31% savings. I'd say that's pretty good. Mozilla says lossy WebP images average 25 to 35% smaller than JPEG images, and they look pretty much identical. So by using WebP images, your website will load faster. Here's the browser support for WebP. Know that there is a Webpack plugin and lots of resources out there on the web to automatically convert your images into WebP format, so you don't have to do that. So the support is pretty good, right? But you'll notice, we have two browsers here who are not supporting WebP. Isn't that interesting? But you might say, well, there's not enough support for WebP. These two browsers over here don't support it, but maybe I should just use something like JPEG and have support for JPEG on all my browsers. There's definitely pros and cons to using all sorts of images. We can't use WebP for all our images on every browser, so what do we do? Well, we can use this feature called the picture HTML tag. That's an HTML standard to load in various image sources. So it's basically a backup solution. So you can see here I have one picture tag and I want to load in one image. When the web browser gets to this section, it will try to load the SVG file first. If it can't do that, it'll try to load the WebP image, and if it still can't do that, it'll try to load the JPEG. So a browser like Safari or Internet Explorer will get to this, and it won't be able to load the WebP, but it'll definitely be able to load the JPEG. So that's pretty cool. Next, let's talk about responsive images and source set. Using source set in our code, we can kill two optimizations at once. So images are pretty important on the web, and getting the right image to the right user is also important. So responsive images means that a mobile user should not get a massive image that a desktop user is getting. Small screens don't need large images. So source set, the idea is to deliver the right image to the right device, and this is an HTML standard. Here's an example of source set. So you can see there are three attributes here. There's the actual source set with the images, and you'll see the image name, where it is, space, and then how wide that image is. And then we also have a sizes attribute, and that tells the web browser, hey, in this case, if the maximum width of this browser is 600 pixels, get that first image. If it is not, then get that second image. That's what it's saying. And if the browser does not support source set, then just load in that third image down there as a backup solution. So source set has pretty good support. Only Internet Explorer is slacking on that one. So I'd say it's pretty good. Now, my final point, delivering fast. We can use a CDN, a content delivery network, to make this happen. And this is actually a pretty cool optimization. So how does the CDN work? I stole this image from Cloudflare, and that is a CDN service that takes your existing code and mirrors it around the globe. So imagine that you actually deployed your stuff to a server in North America. A CDN like Cloudflare can mirror your code all around the globe on different servers. So when a user wants to get your stuff, they'll be routed to the nearest server. So a user in Australia would be routed to the server in Australia, for example. This optimizes the delivery time, reduces latency, and is just better. So to get started, you can use Cloudflare on your own. It just takes a few minutes to set up. And note, by using Cloudflare as your CDN, you're also using Cloudflare for your DNS. It just takes a few minutes, and it's a huge performance gain for not a lot of effort. So definitely look into this one. If I were to do one optimization today, it would definitely be this. So that's all I have. For more on networking performance, among other topics, check out CSS Tricks. They have a lot of cool stuff, not just performance stuff, but just web stuff in general. So next, I'd like to hand it off to Omar to talk about caching and API optimizations. Omar?
All right, so why is caching important? So first, let me start with what is caching. So all of you might use your phones or computers when there's for example, no internet connection, and you might see that you have the page in front of you. So how does that work? So I'm going to move to the next slide to actually explain it to you. So how cache works in the browser is that your browser would essentially download some contents from from like the network, essentially the server. Stuff could be like a CDN, as Noah explained earlier, and it would save it on your local machine, whether it's like your laptop or your phone, and stuff like that could be essentially the HTML page, CSS, JavaScript, could be images, and that's essentially stored on your local machine. So a way to implement cache is by using something called a service worker. So a service worker is essentially a script that's independent from the script that's running on your page, that runs in the background, and it allows you to essentially implement cache. So there's a lot of ways to implement cache, but this is the one I want to focus on today. So this is the classical way to essentially to like render your page, to just basically get your resources and have your web application. So if you see in this diagram here, you have your page and there's your server. So you need 3 HTTP requests. The first one would be, for example, like sending for your home.html, and then your browser would go through the home.html document to see if there's more resources to load. So it would see that there's like a CSS that it needs to like pull from the server, so that's another request, and it sees that there is the JavaScript that it needs to pull from the server, so that's another request. So that would be 3 requests to render like a simple application like this. If you notice, like, so if we now like implement what a service worker with such an application, so we would have like our page, our service worker that's running independently from the main script of the page, and then we have our cache, as I explained earlier, and then our server. So what happens is that the user goes there for like the second time, third time, and let's say that they did not clear their cache. The page would immediately be there because the service worker would communicate with the cache that was downloaded by your browser. And if the content already exists, there's no need to communicate with the server and to get any like resources from there. And that's why it would like load significantly faster. Otherwise, if you're like a first-time user or if you cleared your cache, it would essentially do the same stuff and request the information from the server, which would take longer time. So there is 3 main stages in a service worker lifecycle. The first one is registration of the service worker. Then it's the installation of the service worker, and after that, it's activating it. So to start, I'm going to talk about how you would register a service worker. So in a simple application, let's say we have our web page, we have a main JavaScript file. And then we have our service worker JavaScript file. So we have 2 independent files. So whenever you open your web page, first your main.js file would run, and like it would basically do all the stuff that would need to happen on the page. And there would be some some registration code, which would be similar to something like this in snippet, which I got from Google developers. So essentially what this would do is it would try to register your service worker, and it would communicate with the service worker script and tell it to start the installation process. So if I move to installation, it would basically, we need to add like something to listen to it, like to add an event listener. And that's like where we can start basically doing our installation steps. And you could implement stuff like push notifications, like background sync and stuff like that. And then the final step in having a service worker would be essentially activating the service worker after going through these steps. So, and that is the final stage of doing that. To learn more about the service worker, you could go to this link over here. And that is just one way that you could implement cache, but it's a very effective way and it's very heavily used. And finally, what we're trying to achieve today is to let you know to build awesome websites by making them fast.